Well, hello there out there in geometry land. This worksheet will review the entire unit we've looked over. It might be slightly lengthy, so it might be a little bit time consuming. The way this is set up, however, is that you will be able to do the questions, and working at your own rate, you might want to do, I don't know, like all the questions and then check all the answers. Or if you want, you might try to do question number 1, check the answer to question number 1. Try question number 2, check the answer to number 2. Try question number 3, check the answers to number 3. All right, so all the answers are on this PowerPoint. So instead of watching the PowerPoint first, you should really try to start working on the worksheet first, and then check your answers using the PowerPoint. Okay, so this is question number 1. If you've not figured out the answer to question number 1, you should pause the video. Okay. Remember, we always take the number of sides, subtract 2, multiply by 180 degrees, and that'll get us the grand total for the interior angles. If it's 7-sided, 7 subtract 2, 7 subtract 2 is 5. 5 times 180 degrees. Use a calculator if need be. 900 degrees. So there is the answer with step-by-step work for number 1. Question number 2. Now again, if you've not gotten this done on your own, please stop and try do this on your own. Otherwise, proceed and check your answer. Well, if I know the sum is 1,440 degrees, I know I'm supposed to take the number of sides, subtract 2, and then multiply that quantity by 180 degrees. Well, we should do what first? Divide by 180 degrees. Using a calculator if need be, you come up with 8. Opposite of subtracting 2 is adding 2. 10. The polygon should have 10 sides if that is the interior measurement for the sum of the angles. Again, if you don't have an answer, or if you have not even made an attempt, please pause the video. Make sure you've got something down on paper first. Otherwise, let's take a look. Now, you might have this memorized that 4 sides means 360 degrees, but I'm showing how to find that just in case, right? But any quadrilateral, whether it's a square, rectangle, rhombus, trapezoid, kite, parallelogram, or just some weird four-sided shape, inside it's got to be 360 degrees. So you know the 4 angles must add up to 360 degrees. Surprise, surprise, we've got a little bit of algebra to do. What should you do first? I'd combine like terms. Subtract 304 from each side. Divide by 8. And I get 7. Same deal as before. If you don't have answers, pause. Because they're parallelograms, you know that the opposite side has to be the same length. You know the opposite angle has to be the same measurement. And there are some answers. This was probably one of the more straightforward sections of that worksheet. Same deal, pause if you need to. Because it's a parallelogram, you know that the diagonals bisect each other. So they're cutting each other into two equal pieces, right? Equal in length. I can do the same thing to find h. And now I have the value of both variables. Parallelogram. Which variable should we look for first? Well, I see there's an x and two of the vertices, so I would go with the x. What do we know about those two angles? They got to add up to 180 degrees. Right? They're consecutive interior angles. If you think about the top of that parallelogram is the transverse, and then at the left side and the right side are the parallel lines. Combine like terms, subtract 11, divide by 13, ta-da! Now if I have the value of x, I can find the value of y because I know the opposite angles have to be congruent. So whatever 10x plus 11 is, it's got to be the same as 14y plus 1. Substitute the value we have for x. And now solve for y. Ta-da! Finally, I know that 7z minus 3 has to be the same as 3x. If I know the value of x, let's plug and chug. Plug in the value we know, chug out the other answer. Add 3, divide by 7, z should have been 6. Again, I'm hoping that you keep pausing the video if you don't already have the next question done. But you probably have this down by now. Number 9, what would be the first angle that you would look for? Well, diagonals bisect angles in a rhombus. And if you are a rhombus, the diagonals have to be perpendicular. So now for the third angle there, I'm like, hey, it's a triangle. I know the three angles better add up to 180 degrees. So there's my answer, 40 degrees. Give myself a little bit of space here. You know the diagonals of a rectangle must be congruent. If they are congruent, that means they have equal length. I can set those values equal to each other. I started by subtracting 5x from each side. Then I subtracted 13 from each side. Then I divided by 2. And we have an answer. Uh-oh. We didn't really have an answer. The directions wanted the lengths of the variables. The lengths of the diagonals. I'm getting tongue-tied here. So we better plug and chug. Looks like I'm coming up with 34. Now, this also better be 34, but if I want to double check, I can actually plug the variable into the expression, and sure enough, if I do the computation, I get 34. So that's kind of a nice way of double checking, right? The likelihood of me making a mistake is very, very, very small, because if I made a mistake, I probably would not get the same value for each of those. Right, because they better be congruent. In other words, equal measurement. Okay, number 11. Isosceles trapezoid. The base angles have to be congruent or equal measurement. I know the four angles better add up to 360 degrees. I know measure of angle T and measure of angle S have to be 82 degrees. I know the measure of angle B is the same as the measure of angle A, so I did a little substitution in there. Subtract 164 degrees from each side. Divide by 2. And of course, if I know the measure of angle B, I also know the measure of angle A. Okay. Trapezoid. It's a mid-segment. We know the mid-segment has to be the average of the bases. And I should have said the arithmetic average, right? Because there's more than one type of average. I should have said it's the mean of the bases or the arithmetic average of the bases. Add them up, divide by 2. Bingo! There's the length of MN. Again, we know that if we find the mean, we've got the length. So X has to be 8. Okay, so here comes probably perhaps the trickiest of the bunch. I know that X plus 1 plus 8X divided by 2 has to be the same as 5X minus 1. Right? The distance from M to N is the X plus 1 plus the 8X, and that entire thing divided by 2. But I also know that MN has to be 5X minus 1. Algebra time. What would be a good first step? I would combine like terms in the numerator. X plus 8X is 9X. How do we deal with that fraction? I don't like that divided by 2. That makes things messy. Multiply both sides of the equation by 2. That will eliminate the fraction. Right? 2 times 5X is 10X. 2 times 1 is 2. On the right-hand side, the 2's cancel out. Leaves me 9X plus 1. Subtract 9X from each side. Add 2 to each side. Viola, X has to be 3. Kites. Well, there are 4 vertices. So those 4 angles have to add up to 360 degrees because it's quadrilateral. And in a kite, we know that angle E and angle G have to be congruent. Or in other words, the measure of angle E has to equal the measure of angle G. So I'm going to substitute the measure of angle E with the measure of angle G. And of course I can plug in the values of 42 degrees and 104 degrees. And so I can combine like terms. I've got 2 times the measure of angle G. And then if I add the 42 and the 104, I get 144. Subtract 144 degrees from each side. Divide by 2. Do, 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 do. And we'll do something very similar to number 16 once we get this silly parade of cows going on by. Hey, no, they're not going to go by, they're just going to stop. Okay. Know the 4 angles must add up to 360 degrees. I know angle G is congruent to angle E, so their measurements must be equal. I can do a substitution. I can plug in the values I know. Combine like terms. Subtract 230. Divide by 2. Ooh, it's a kite. And so we all know it's going to shake with a kite. Those diagonals are perpendicular. So I can do the Pythagorean theorem. So distance of AB has to be 5. And of course the distance from A to D has to be congruent. And then I can use the Pythagorean theorem to find the other ones. Right? 4 squared plus 12 squared has to be equal to the value of the hypotenuse, which happens to be BC squared. Oh, far more interesting. What can I do with 160? 1 times 160? 2 times 80? 3. 3 won't work. I could do 4 times 40. Can I do better than 4 though? Because I can take the square root of 4. 5 times 32. 6. 7. 8 times 20. Can't take the square root of either one of those. 9 will not divide in there. 10 times 16. 10 times 16. Now we're off to the races. Square root of 16. That is the largest perfect square that is a factor of 160. Right? I could have tried 4 times 40, but I'd have to do an extra step. So instead I want to do 16 times 10. 16 is the largest perfect square that is a factor of 160. And of course, square root of 10, all I can do with 10 is 2 times 5, so that will not simplify. And of course, because of this being a kite, we know we have a situation where we've got a couple of congruent sides here. And get over there 4 root 10, my goodness. There we go. I think we got, what, one more question coming? Same situation where we're doing use the Pythagorean theorem. And so there we have it. Looks like we're happily riding off into a beautiful, fantastic sunset. So there is an IXL. Remember, if you log on and don't see a geometry tab, it is a level L tab. And for some bizarre reason, our beautiful sunset rejoins us.